Merci Christian Michel pour l'introduction. Je vais parler en anglais pour cette présentation. My kids would say my French is like this compared to their papas who's Quebecois, and his French is like that. But thank you very much for inviting me here today to talk about pre-competitive data. We're going to go through a little bit of an introduction, introduce some concepts about what this means, assess the current situation in Quebec, go through some case studies around the world, see what other people are doing in this realm, and then make some recommendations for where we can go from here. So to start introduce with, McKenzie and May published a paper in '92. There's not a lot of formal research done on this realm specifically, because the idea of project generation generally is not very well documented. It's really a competitive advantage of companies, how we come about defining where we go to explore. But they put through these concepts in their 30-year assessment of what was done in Australia about exploration research being the main driver of project generation. And this is not typical exploration activities. This is scientific undertakings to achieve the objective of generating projects. And really, they underline this concept that I think we all intuitively know in this industry, that there are substantial rewards held out for the successful in mineral exploration. So how we come to peg that ground initially is the most jealously guarded competitive element of all. So we're defining here today pre-competitive data as data sets that are collaborative. They meet an industry-wide need, and they're usually one of the 3 Gs, geological, geophysical, and geochemical. And they're made available to interested parties to then carry out early stage mineral assessments before committing major funds. So this is a good graphic put forth by Geoscience, where you can see with the green side on the left is where the pre-competitive data generally falls in the exploration pipeline. Priorities generally assigned to regions that are prospective but underexplored. It's good to just take a step back and think about where we sit in the wider economy. A few snapshots from NRCan's Facts About Mining, the most recent release here in 2018, is that mining employs 426,000 people in Canada. We have significant expenditure, 12 billion in capital expenditure, and in total natural resource exports total 47% of our exports to 236 billion. So assisting how these mining projects are generated is really a critical element of our economy. So McKenzie and May in the '92 paper did an assessment from the 60s to the 80s, and then Ken Witherly, my colleague who I've prepared this talk with, brought it up to the present day. So an enormous amount of exploration data was collected from the 50s onward. And if we break it down by decade, in the 60s we see new technologies, importing professionals around the world to new jurisdictions. Land access was generally easy, and the need for pre-competitive data wasn't really strongly felt during this time. As we transition to the 70s, where we're seeing more areas covered with pre-competitive data, the discoveries made are more technical in nature, maybe not economic, and land access is starting to become more difficult, and some hindrance is happening in terms of mineral development. And the thought of importing concepts from other jurisdictions is not really working anymore, and so the need for exploration research is starting to become apparent. And then in the 80s, there's a more sophisticated approach to exploration, less important professionals, jurisdictions are starting to develop their own expertise. We're seeing some success in more complex environments. Access to land is becoming a big problem, And PC, the pre-competitive database, is lacking coverage, quality, and timeliness, so industry is starting to go in and co-fund big compilation projects. So by the end of this, this 30-year grouping, we're seeing real industry recognition of need for pre-competitive data, that it levels the playing field, it's suited to longer-term activity, it spreads the risk, that you can access large groups of land, different topics, and the jurisdictional geoscience groups are really the main drivers of this activity. Now, if we go into the 90s to the present, we're seeing a lot of new geophysical technologies being developed. We are understanding that exploration under depth is critical. We have, of course, the BRIEX scandal and accountability is coming into play. And innovative purpose-funded pre-competitive programs, I'm thinking of like Operation Treasure Hunt, Lithoprobe, these types of research are being conducted. So substantial funds are now starting to get committed. In Australia, for example, they spent $270 million in the late 90s. In the 2000s, we remember the enormous spending and acquisition of assets. Emphasis was really on size of discovery, but there was also a discovery slowdown. And so the super cycle and corresponding super crash maybe related a lot of data collected, but was it the right data and what can we do with this data? And although funding is starting to get slashed to jurisdictional surveys, they're still moving forward with pre-competitive programs. And now in this latest decade, the 2010s, we're starting to catch up with exploration. As you may have been aware, machine learning and data integration are really key themes of lately. The market's starting to recover. We're seeing both, although a lot of focus on producers and brownfields. And these large research programs are really starting to become underway, like the TGI program, Metal Earth, Telescope into the Earth, these kinds of things. But I think that there's still advocacy necessary for understanding and promoting pre-competitive data to help with project generation. These slides are from Richard Shoddy's diagram and from Richard Shoddy's presentation, and he plotted from pretty much the 1900s to present major discoveries and how the land behind these were first decided to be pegged. So you can see in the blue, which is tapering off into the 60s and 80s and then be pretty much non-existent in the 90s to present, is the prospector-driven discoveries. So we're seeing that taper off. At the bottom in the red is the geophysics. It's sort of come online during this era but flatlined. Same with geochemistry. There's been some up and downs, but it's pretty uniform across. And the major thing we see here is the brown, which is geologic mapping, and the tan, light tan color is exploration extrapolated from no mineralization. So to us, we see really a dominance in brownfields exploration based on these findings. In the future, we need to go beyond the just traditional geologic map, and we really need to, I think the explorers are really driven by computer power today and the need to move beyond brownfields. There's a real appetite for raw data with machine learning, prospectivity, and just general processing. But the need here is to move on from brownfields and into greenfields, and this is where pre-competitive data is critical. There's a cost benefit to pre-competitive data. So it's wide-ranging in the literature from what we found, ranging from $3 to $5 for every dollar spent to $10 to even as much as $15 for every dollar spent. So even if we're conservative and stay at the $3 to $5 range, it still represents not a wealth transfer. but a wealth generation. And in the short term, the idea is to stimulate exploration, but the long-term hope is to develop new mineral resources. So let's take a quick look at the situation in Quebec. I have a fondness for Quebec. My husband is Quebecois. As an Ontarian, I can tell you things work differently here. But Quebec has always done really well in the Fraser Institute rating. In 2017, they were ranked 6th in the Attractiveness Index, and overall, they've risen dramatically in the last 5 years from 24 to number 6. They're really good, well done in Canada. They're number 2 behind Saskatchewan, but the important thing is they're ahead of Ontario. Digging down a little bit, there's a policy perception index in the Fraser report, where one of these, it's a composite index, so one of them is focused on the geological database. And in here, this is things like the quality of maps, the scale, the ease of access to information. And I was surprised to see Quebec ranks number 10, which is still ahead of Ontario, but behind places like Nova Scotia, Newfoundland, Yukon, and BC, which surprised me a bit. We know that Quebec has a wonderful, diverse geology. The sheer size is amazing, 1.67 million square kilometers, with the greenstone belts to the Labrador Trough, down to the Appalachians and St. Lawrence platform, the Canadian Shield. We have a variety of deposit types across the province. And although there's a lot of exploration ongoing, the question is where has that activity been focused, and are there underexplored areas? I did a little bit of armchair research into the CIGIOM through the MERN website, and took a look at the coverage. And then I participated in a panel of Geophysics where they displayed what they're doing and where they're going in the future, and it's really quite good. I think this MEG map might not actually be complete. There's more there, and there's a real commitment in the top right. You can see the MEG to covering the province with this 200 to 300 meter line spacing data. The terrain clearance still pretty high, 80 to 120. There's a ring around the north of Quebec with the radiometric data, and I think there's also a real appreciation for the interpretation aspects of that. The EM data, I think, is a bit misleading. It's the anomalies, but in speaking with the people here in Quebec, I think there's only a megatem and input surveys in the sort of Abitibi and some frequency domain in the St. Lawrence platform. So these represent maybe EM anomalies that are in the assessment record, but not a lot of EM coverage in Quebec. There's the CONSOREM, which was interesting research consortium. They promote exploration technologies in Quebec and link different people who are active here, members in the industry, government, and academia, and try to create a dynamic relationship. If you pay to be a member, you can have access to this portal. There's a moratorium period where the data is only kept amongst the members, and then after that period is up, it's released into the public record. And the comment here is that it's wonderful, but it's the key players in Quebec are aware of this and not so much outside of Quebec. So Ken and I sat down and did a gap analysis on the situation in Quebec. And so what this means is we outline what the situation is currently. We'll go into what we want to see and propose an action plan. And so the situation for geophysical coverage is good. There's moderate coverage, moderate resolution. We have some transects from lithoprobe. There are some interpretation products out there, mineral potential maps, 3D modeling maps, target maps. The data distribution on CIGIOM has been free since September, and there's the CONSOREM, if you're a member. And then the awareness of it, I would say it's a bit insular. It's really high within Quebec and maybe not so high outside, or understanding of it outside. So we'll go around the world a bit, and there are numerous case studies on individual jurisdictions, pre-competitive data, and here are just a few highlights that we've found. So we'll start in Finland. Finland, the GTK, the Geologic Survey of Finland, is really ranked highly and considered a global quality benchmark. They have really committed to high quality, tightly spaced data since their inception in 1885. They have a pretty big budget, 45 million euros and 450 people working with them. They have a very clear one-page strategy or vision of the future for 2050, where they want to be a global leader in mining. And so they want to promote their domestic growth. They want to propose solutions globally to mineral exploration challenges, and they want to mitigate environmental impacts of mining. So there's a real key learning, a commitment to high quality, full coverage, and being a global leader. If we move over to Ireland, the TELUS program by the GSI is collecting geochemical and geophysical data across Northern Ireland and the Republic of Ireland. They have a broader mandate. It's not just limited to mineral exploration. They're examining the chemical and physical rock properties of soil, rocks, and water of Ireland. So in addition to the mineral prospectivity stream, they have an agriculture stream, an environmental health stream, education, and climate change. So they are about 50% complete now, and my understanding is that the individual mining companies co-funded to fly specific areas first. But there's certainly been an uptake in prospecting licenses, and although the mining companies go and download the data, there's been a lot of work and effort put into developing products and educating, especially for the other streams, what this data means and how it impacts in their work streams. Australia's doing a lot in this space. So you may know of the Deep Exploration Technologies program that was wrapped up in 2018. They had a $155 million program there. One of their projects was to develop successful, cheaper, safer ways to drill, and the coiled tube drill is an example of this, one of their achievements. So they're trying to find faster, quicker ways to test targets. And this story goes with the Minex lab at the rig story that Ken likes to call the fairy dust story, in that it's real-time analysis as this material is coming out of the hole. And this is something that was brought forth by Robbie Rowe and Tim Crass in terms of trying to radically transform how we do exploration from something that we call exploration 1.0 to discovery 2.0. So we have maybe the junior person at the rig, how do we communicate this information to all the parties that need to make the decisions. And also if we go from drilling 1 hole a week to 3 holes a day, that requires a paradigm shift as well. But it's one possibility for going around and targeting into the greenfield space. Australia is also very aggressive in airborne geophysics. They recognize that 80% of their country is covered. They've recently announced this huge EM survey, 1 million line kilometers, which is the size of France and Germany combined, up in the Northern Territory in Western Australia. And they're doing this with CGG Airborne, but they're also doing some stratigraphic drilling of the results to better understand them. So it's not just about flying the survey and giving out the data, there's an element of follow-up to that. And there's a lot more going on in Australia. We have CODES, which is a global leader in ore deposit research, Center for Exploration Targeting, the downward-looking telescope where they're trying to look 300 kilometers into the Earth. There's Uncover Australia that's, again, trying to improve success rate. So they're really trying to think about these problems that we're facing in mineral exploration and put funding to how we can overcome them. Let's move over to Africa now. So the Botswana Geoscience Portal launched in 2016. This put out 10 gigs of multidisciplinary data in collaboration between Botswana Geoscience Institute and Geosoft. The focus is on the Gamaland region in the northwest initially, but they've got some other products for the rest of the country. And what I thought was interesting here is that the Geosoft was able to really track who was downloading what, where they were coming from, what products they were interested in. And so two highlights were that a lot of interest was, a lot of downloads did spike when it first launched from all over the world. A significant number of majors went in and took a look at the data, but also locally too. There was a lot of interest within Botswana. They were the second highest number accessing the data sets. The World Bank is doing a lot of projects in Africa and elsewhere, and they're doing things like helping Nigeria diversify out and away from oil and gas and looking at their mineral sector. There is this new program called the African Mineral Geoscience Initiative, or they've nicknamed the $1 billion map of Africa, supported by the Korean International Corp. Some fundamental geologic works going on in the DRC. So they're doing a lot, and they've kind of stated that doing this pre-competitive work is just as important as other infrastructure work in terms of attracting and developing the different sites in Africa. So let's go into our own backyard here in Canada. The GSC NRCan is doing two key projects. One of them is the geomapping for energy and minerals. They're trying to modernize the picture of the north. They've got a focus on 6 key areas up there. They're committed to 2 million line K, sampling, a lot of stakeholder engagement, and they're planning on publishing over 1,000 maps and reports related to this program to really generate and stimulate exploration in the north. The other thing they're working on is the Targeted Geoscience Initiative, the TGI, and they're trying to address the problem of decrease in reserves and metals in Canada. So they're taking an ore system approach. They've got a focus on different ore systems: uranium, porphyry, gold, nickel, copper, PGs, volcanic and sedimentary systems. And so they're taking that approach. They're doing targeted and sometimes deep exploration initiatives, trying to figure out vectors. Here on the right is a screen cap of recently released mag and airborne gravity gradient data, as well as mag and EM data collected in Saskatchewan. And they're also training and mentoring students to help provide more qualified personnel into the industry. I've got to put one little slide about Ontario in there. We had a almost $29 million 3-year program in the late 90s, early 2000s called Operation Treasure Hunt to attract mineral investment, and that was focused on time and frequency domain EM across the central part of Ontario in specific geologic domains. And that did trigger a staking rush. And at the time, after, there was a really high satisfaction rate with the program and a willingness to reinvest in Ontario. Out of BC is a sort of an ongoing program is the Geoscience BC, which is a nonprofit organization that was initially funded with an endowment from the BC government. And they are doing, again, geophysics over our belts of high mineral potential, so mag, gravity, EM. And the QuEST program in the Central Corridor, when that was first announced and released, that also triggered staking rush for the 438,000 hectares. And the story continues across Canada. Like, each jurisdiction is doing something different. The Northwest Territories is flying specific surveys. In Saskatchewan, there's incentivized drilling in certain areas. And even Nova Scotia has just released a report talking about that they want to be a free, best-in-class database of geophysical knowledge to promote their mining industry. So they're thinking big and putting themselves out there. So if we come back to the gap analysis, so I think what we see and what we learn about all of these jurisdictions is that we want to fill in the gaps. And there seems to me to be a real commitment in Quebec to do that, to fill in the airborne gaps with high resolution data sets. I think broad scale EM should be considered, or in areas of high potential. There's also a need, I think, for deep transects, but more importantly is to consult stakeholders and determine where these should be. Interpretation products, I think, are also important. We want to have transparent interpretation products. We understand what they mean, and there's an element of education that goes with that. And continually updated with field data. I think it's important to collect rock properties, for example, to tie this in together and make them repeatable and continually update. For data distribution, we're good. We can be the best in Canada. We want to see a well-organized, free, easily accessible. There's a lot of information out there in Quebec in terms of the assessment record, CGL, CONSOREM. I think it all can be filed into one place. And then finally, just to make it more aware, a more well-marketed, well-known jurisdiction. So where do we go from here? Well, exploration has changed into fundamental ways. We are now looking undercover, and we're thinking more about the mineral system. So there's a feeling that we'll probably be transitioning from low-grade, large deposits to smaller ones with lower ecological footprint, but are deeper. And this transition will happen when the necessary technology accompanying it, deep drilling, robotic mining, becomes more viable. So it behooves the government to think about where industry is going, how they're thinking, and how we can tie in the pre-competitive data to this situation. We need new thinking in the mining industry. It goes beyond just visualization of data. There's a real appetite now and effort underway, I think, to apply machine learning and artificial intelligence into the exploration space. If you think of all of the data that we collect, all of the geochemistry, geophysics as a parameter or a dimension, if you will, we really have tens to hundreds of dimensions of data, and how do we relate that is more, we need more than maybe the human brain. We still need the geologist and geophysicists to put it all together, but I think that these tools are really going to help us here. We need to collect better purpose-fit data. We want to collect rock properties, design surveys and campaigns that make sense for the environment that we're in, and focus on education and support of the mining industry. I think is a bit required, that we can't just keep doing the same old thing. The geology and geochemistry story is quite good. Elisabeth, my colleague, is always impressed with the database in Quebec on this side, the detailed mapping. The survey's doing this already. There's systematic multi-element geochemical surveys across the province. There's some geochronology, but there's a cost-benefit question to that. Maybe you want to leave that to deposit stage. The mineral system studies are really underway, and although academic, I think industry is taking what it finds and starting to build that into their model. And then the question of ground truthing, are we going out there and seeing what we're, validating what we're collecting in the geophysics, that could probably be improved. We want to strive for better airborne coverage. We've talked about this already. I think we can get high resolution data, and there's a real commitment to this. I think we can improve that Fraser geological database score by putting it into assessing the data fitness and then putting it into a platform that's easily accessible. Well, maybe go for EM in strategic places. That's something that we should be working and consulting with this appropriate stakeholders. Through an AGG and FTMG, I feel like my children who are asking for an iPad, an iPod, a Switch, and a fish for Christmas. And I know that some of these are very expensive. Maybe we'll start with the fish and go from there, but I guess if we don't ask and we don't think about it, and sometimes certain jurisdictions are charging ahead with it, like Australia, they're doing more, thinking more really big picture, and finally centralized data distribution. The need for deep imaging, this is really coming into play now. I think that could be natural field methods collected, like ZTEM, EM. That's really a dialogue, I think, with the stakeholders. MT, seismic, this is a section of Olympic Dam. Somebody called it the fingers of God. The fluid, which outlines the fluid melt pathways on the MT. And so thinking about these, it's really complex. And again, presents challenges for end users in terms of processing, interpretation, and how to use this. Interpretation, to interpret or not interpret. We had a lot of debate about this. I think it's to the benefit of the agency that's acquiring the data to at least do some interpretation. I understand that private companies historically have done the interpretation, but I think it will help improve our overall success rate if we get on the same page about what we're seeing. This involves a need for physical rock properties and integration, and I like this cartoon that displays this idea of data integration, because we go out and do all of these complex surveys, like the 5 blind mice here are doing their own surveys right now, and then they get back together and try to put the story together, and then they present their results, which is not exactly the elephant, but is a lot better than the individual parts. It's closer to the elephant than the individual parts. So what does it mean for Quebec? Well, I think if we go back to the gap analysis and come up with an action plan, I think we need a real commitment to understanding geology through high-resolution geophysics, and a forum with explorers where we can integrate these things. I think interpretation products, rock properties for a start, are great. We want to do education and make the public aware of what these potential maps, inversion products, target maps are. How are they repeatable? The data distribution is important. We want to do a fitness test on everything that we have and try to find a way to streamline it. And finally, generate some buzz about what's going on. Come up with a marketing plan. There's a lot of information here that's really useful and can really elevate Quebec to the best in the world. But it all requires this fundamental underlying strategy that Quebec wants to be the best. So, in conclusion, pre-competitive data is more important than ever before. These deposits are getting harder to find. Our search needs to really go into the greenfield space now. The investment community's lost their enthusiasm based on our last 10, 20 years of results. The juniors just don't have the funds to undertake these large pre-competitive programs. The majors don't want to do the commitment. They might go and fly areas and cull and take they might cull what they want out of it, but that data doesn't go into the public record. And so no one's investing in this critical area, and so that to me means that de-risking greenfields falls to government. So the recommendations for the future were good now, but we recommend to try to strive to be the best, to display a clear and concise strategy of where we want to go, to do the fitness test of the data and streamline its distribution. We want to get input from all stakeholders, including explorers, and embrace these new technologies, interpretations, and do things not just because that's what we've always done, and provide education and support, and finally let's generate some buzz about what we can do out there. So on that note, thank you very much. It was a real pleasure to talk about this subject today.
Thank you very much, Jenna. Est-ce qu'on a des questions du public? Il nous reste encore quand même.
I'll use the microphone. You put up something about 20 slides back on cost benefits for geochronological acquisition data. I really didn't understand what you meant. It's too high, it's not good, we shouldn't do it.
Yeah, that was a comment from my colleague Elisabeth, who is a geologist, and she thought that maybe it was a bit high to do age dating. I'm not really familiar with that. If it's if we're collecting the rocks and it's easy, and maybe it is helpful to do. But her comment was maybe it's more for when we're getting into deposit scale to do some age dating or understanding.
So she thought it was better applying to deposit scale than a regional scale.
She just was concerned with the cost, I think.
Okay. A second very quick question. Why do you think that the data that we generate in Quebec has an insular quality to it, whereas other much smaller countries, Finland, seem to do much better at Botswana in order to promote, because that's what you put up, Botswana generated a lot of interest from outside majors. And I did hear you say that for the Quebec government data.
I think it's more perception from talking, but also it's been experienced that it's difficult to get information, or you need to be a bit more of an insider. That being said, I think there's been a real transition to improvement into distributing data to the outside world, but I think that the point of those other countries is that they're trying to just let it all open up and see what comes in, and the investment back into the country is what's important. So they want to tell everyone that they're doing, this is what we're doing. I don't know if Quebec does that as well as these other jurisdictions.
If you'd like to use the microphone, please, to ask your question.
I have Richard Smith from Laurentian. I had a student that did a compilation of IP and resistivity data from the Malartic mine area, and had to get the data off the website. The student needed a little bit of help, but once they got the help, they managed to purchase all the maps that had been collected and all the sections that had been collected in that area. And then we had to go through the process of digitizing that data and turning it into digital data that we could work with. So I think this is a general problem data that was collected in the 80s wasn't necessarily digital data, and now people are demanding that sort of digital data. So I think a challenge for the jurisdictions and people like the ministry in Quebec is to make that old analog data digital and available to people so that they can start to work with it straight away. So, I was talking with IBM, and they have a big group that's involved with digitizing data. The technology exists to digitize data. So this is, I think, one of the next challenges for the jurisdictions is to take that challenge and make that old historic data available. So I guess I'm throwing out the challenge to the Quebec ministry to take that on. Maybe that would be something that they could show some leadership in.
Yes, I agree with that. There's a wealth of information in the assessment record, in reports, in the backs of appendices and whatnot. But it will take an effort to do that, but I think the cost to do that compared to flying or collecting new data is pale comparison. So I think there's a lot of value in doing that. And again, that goes to that idea of the data fitness. So not every single survey out there may be usable or able to upgrade our knowledge, but there's a lot in there that can. So I think we should really work on getting that more accessible. Agreed.
Frank Glass, I live here in Quebec. Maybe 2 comments, but the most important was, I hope most people noticed on your slide for Australia, the objective to map from the surface down to 300 kilometers. This requires good education for most of us, not at a high level, but at a general level. It's not black magic, it's not at all. It's good scientific information. It's very important in my opinion. It's a real struggle for me to understand from the surface down to those depths what creates homogeneity of the features that we can see at the surface. Second point, the surface at which we look and all the data we collect from the surface is basically a frozen tablecloth on top of the table. What I try to do is look for the legs that support the table. That helps a lot of fluid flow. A third point, Claire Sampson did with University of Ottawa, a PhD student, taking aeromagnetic data of Canada and transforming it to the Curie temperature, which is basically a frozen heat flux of the relict crust. These are very good, and I think the future, the fourth comment for us, or not for me, but for the rest of the world, going ahead is wonderful. But it requires a lot of general education, a lot of curiosity, and the desire to look into the data and find what you want to look at. Thank you.
Thank you. Yes, I think you raise a good point, Frank, that speaking with James Sidorn, we were talking about the differences between geologists and geophysicists, and how geophysicists, when we're doing imaging, we're really just taking a snapshot of what's the current situation, and geologists are thinking more about the time and the processes. So I like that analogy of the frozen tablecloth on top of the processes behind what's happening. Yes, you're right. It's going to take a lot of education and curiosity.
Il nous reste peut-être une autre dernière question, si quelqu'un qui en a une. Sinon, j'en ai une. You've spoken about basically ground truthing the data and the interpretation. I know that Australia does it, but are there other jurisdictions that also provide this ground truthing?
I know that they do, for example, at the GOC, they do some ground truthing in their GEM program, and also I'm aware of it in Africa in different World Bank surveys, like one that PGW did. I can't remember if it's Nigeria or Uganda, but they built that in as well. And I believe India does too. So I think it's important to go out and walk on the ground and It's not all in theoretical space, but looking at the actual rocks and trying to make sense of what we're seeing in the data is really an important step.
Thank you very much.
One on the ground truthing is in Finland. Jenna showed some maps of the regional data, but they have been going on for decades getting high-quality petrophysics to merge with those regional data sets. And that, I remember Gordon West in the 80s, he married a Finnish lady and he had the opportunity to visit. And he says, I've never seen anything like what they've done in Finland with the petrophysics. And I still stand in front of audiences and many of my colleagues, largely geologists, and saying, you've got to get more petrophysics. So that is an important thread to pull all of this together.
Thanks, Ken. Merci, Jenna.
Thank you.